In Chapter 3, we're going to further develop the idea of the connection between the algebraic equation and inequation, in this case, and the graph. The graph is a wonderful example of a visual interpretation of your equation, or a graph can represent a solution to solving an equation. Now, you saw that back when, you saw graphs working when you were instructed to solve some simultaneous equations graphically. So you drew your two graphs and you looked for where they intersected, and the point of intersection became your x value and your y value that made the equations true. We're also going to see graphs of the solution, graphing the solution, and that is in particular with inequalities or inequations. It probably doesn't surprise you that we're going to start by looking at linear inequations, and that will be followed by quadratic inequations. Now, with solving linear inequations, we don't use the graph to solve one. However, we do use the graph to graph the solution. We can graph the solution. So, difference there, we don't use a graph to actually solve, but we do use do take a solution and graph it. Now, we're solving linear inequations, and we know that an inequation just has a less than or a greater than sign in it. Then we treat them basically, we treat solving this like an equation unless we're ever multiplying or dividing by a negative. Now, that's not the same as adding and subtracting negatives or introducing a subtraction of a number. It's strictly only when you are multiplying or dividing by a negative. And if you do that, if you find that you really have to divide by a negative, then you must swap your inequality sign from, for example, a less than to a greater than. Okay, let's have a look at this solution. This first example. Now, we're really going to practice taking a little moment at the beginning to register the instruction and think about that. Solve. What does that tell me? Solve means I'm going to find the value of the pronumeral. And in this case, the pronumeral is x. So my very last line will be x. I'll have x all by itself, because that's what to solve means. You're going to get x all by itself. And taking a little bit more time, we can see this is actually an inequality. So I'll have let x maybe less than, maybe greater than, just depending on how the solution pans out, and certainly the numbers on the other side. Looking then more closely, I can see a fraction here, and what will become really important, not so much here, but in a few examples' time, is that the denominator here is just a number. I'm just going to put a little star next to it, just to help draw your focus to the denominator. With an inequality, we need to register, if there's a fraction involved, we need to register what is actually in the denominator. When it's a constant, we don't have a problem. No problem with that. We've got less than or equal to and an x. So we've got x on both sides. I'm going to pause the video and write the solution up, because this is a fairly straightforward question on solving a linear inequality. There are no problems complications with it. Like I said before, just treat this like solving an equation. Unless, of course, at some stage I want to multiply or divide by a negative. Okay, so there is nothing complicated in this solution. We will multiply both sides by 2. That requires no change in the inequality. Multiplying this side by 2, we just get x plus 6. This side by 2, we get 2x. Now, I want to keep positive x's, so I'm going to take this x to the other side and subtract it. And plus 6 remains. 2x minus x is x. And now I have to read this in reverse, which says x is greater than or equal to 6. X is greater than or equal to 6. You can see here I've drawn a number line, and you know I can't use the ruler on the Surface Pro because it doesn't register it. But please, when you're graphing solutions, please use a ruler. Mark off your scale accurately using your ruler also. X is greater than or equal to 6 becomes a closed circle on 6 because 6 is included. And we know that greater than is to the right-hand side. And the other thing that we should always check is the way the arrow points on the end of our solution line. Is it the same as the arrow in the question? And yes, it is. With the second example, again, we do have some fractions, but we don't have anything terribly troublesome. There's no x in the denominator. That's the important thing to register. There is no x in the denominator. Like I said, I'll keep emphasizing that because when we do register x in the denominator, we have a very different solution method. So I'll pause the video, write up this solution. We know that our last line is going to be x is something greater than, less than something, a number. And there really possibly will, only complication will be maybe simplifying the fractions. Okay, so I chose to move the x minus x on 4 to the other side, and it made that a positive. And the plus 12 came to the left-hand side here and became minus 12. In the next line, I'm trying to simplify this to get it down to a simple x. And I am getting a common denominator. The common denominator between 6 and 4 is 12. This fraction needs to be multiplied by 2 on 2. So the numerator becomes 2x on 12. This fraction would need to be multiplied by 3 on 3. So it becomes 3x on 12. Now, you can see I have bracketed the numerator. I've got this over 12. I don't want it over 12, so I'm going to multiply by 12. If I multiply this side by 12, I don't need to make any change to my inequality because I'm multiplying by a positive number. And I can multiply what I've got here, which is negative 12, by plus 12. Simplifying that, I get negative 144 greater than or equal to 5x. 2x plus 3x is 5x. I've just turned that around as 5x is less than or equal to negative 144. Dividing both sides by 5, again, does not require any change of sign. It doesn't matter that we've got a negative sitting on this side. And x will be less than or equal to negative 28 4/5. Now, over here, I haven't mentioned this, but although these inequations involve fractions, please note x does not appear in the denominator. The reason I'm emphasizing that, and you might think, well, that's an unusual thing to emphasize. The reason I'm emphasizing it is because when it does, which is what this goes on to say, when this does happen, x is appearing in the denominator, we've got a very different method for the solution. Now, we're going to stick with the inequations, solving them, and we're going to leave linear for the moment and move into solving quadratic inequations. And I would always strongly advise you do this graphically. It's so important to me, this exercise, that you recognise the situation and that you follow this method of solution, that I'm going to address this in a whole nother video. We will come back to this situation here where we're talking about x in the denominator, and again I'll produce a whole nother video on that, because again, to me, that's so important. It's a really common question. It deserves to be treated by itself.